X is the length of a particular leaf which is normally distributed, mean and variance. They ask us to find the probability value as given. So let's try. We take the X and we're going to convert it into Z. So I have mu minus sigma minus something, divide by standard deviation, Z, convert mu plus sigma, then you will minus something. So what will that be? What is your mean value? Mu. What is your variance? Sigma squared. So you write your mean here, and this is only the standard deviation. By doing this, what have we gotten? Can you see the mu and mu cancels off and leaving me with -1? And this side is 1. So let's try to draw our normal distribution to see how it's going to look like. Middle 0, 1, and then this is -1. So if I can find what is this probability, I can just multiply by 2. So you can read for Z less than 1. So find what is this, and then you minus 0.5. So if I do that, when I read for Z equals to 1, what do I get? 0.8413. So minus 0.5, you're going to get 0.3413. I will take this area and I will multiply by 2. So what am I getting by doing this? 6826. So that is the value of this. Second part says I have to look for probability where the length of leaf is more than 2 standard deviation from the mean. I don't quite understand the meaning of more than 2 standard deviation from the mean. All I know so far is if this is my X, then the middle part is going to be mu. From the mu, it is 2 standard deviation. Let's replace the 2 standard deviation with a number first. Maybe this is 3, and then I'm going to replace the mean with 1. Okay, let's see what happens now. If my mean here is 1, so it has to be more than 3 from the mean. So this part is 3, right? So what is this value that you will get? 4. More doesn't mean you only have to look on the right hand side. You can also look at the left hand side. As long as the gap is 3, more than 3 from the mean. So there is a left hand side boundary with -2. So this is what's happening. If it is very confusing for you, just change it into a number like this. Now you can write this easily. You know that this part is going to be mu plus 2 standard deviation, and this part is going to be mu minus 2 standard deviation. If you're alert enough, you will realize that when you convert this into Z, this part is going to be 2 and this part is going to be -2. Why do I say this? Because if I take this value, I just have to minus a mu and then divide by sigma. Don't you think it is giving me a 2? So now our aim is to look for these values. So what I can do, I can just look for one side and then multiply by 2. From the table, when you read for Z equals to 2, you are getting probability value of 0.9772. So where is this 0.9772 in the diagram? It's this part. All of this till the last value that you can get. This is 0.772. What will you do to get this part? 1 minus 772. And then you take that and multiply by 2. Let's see what you're getting. 0.045 6. Now part C wants you to find the mean and standard deviation, and they have given you two equations in terms of probability here. This is quite simple. So how do we go about this one now? Just convert this into Z. Convert this into Z first. You will be writing first one, and your second one is 0.9. Area is 90%, shading less. How will your normal curve looks like? This is your 90%. You have shaded to the left according to this part. So my Z is positive. And how about this? Also similar scenario. This is 75% now to the left hand side. And your Z is also positive. So go and read from your table. For P value 0.75, what is your Z value? 0.674. It is written at the bottom here. Easy reference, go to the bottom part of your table. And then when you read for 0.9, we get Z value as 1.282. Everything becomes easy. Take the Z, compare with the Z. Apple compare with apple. P compare with P, Z compare with Z. So 7.5 minus mu divided by sigma is equal to 0.674. Do the same thing for the bottom one. You keep working. Let me shrunk this. Okay, so when you write it, you get two equations. You make it into you just bring this up. I got two equations and I have two unknowns. So it's easy to solve. I just have to take this and minus. So when I do that, this is gone. I get a 1 minus your sigma value is going to be 1 divided by the answer 1.64. Use this sigma value and you find your mu value, and when you do look for the mu value, do not just substitute this. Your calculator is actually giving a more accurate answer, so use everything from the calculator and substitute in any one equation. You should be able to get your solution. Your mu value is 6.39.